Financial Modeling, Topic 11, Default Adjusted Bond Returns, Section 4. We're going to create an end period model to compute default adjusted bond returns. So I'm going to go to my spreadsheet. In Sheet 3, I have a transition matrix, which we explained in Topics 1 and 3. I also have a bond we're looking at in Topic 2, which is the B-rated 2-year bond, has 50% recovery rate in default, has a 10% coupon. It's currently selling for $90. We're going to calculate this. The spreadsheet is going to calculate the default adjusted return right here. But I need a couple things to compute first. That is, what are the cash flows as a percentage of par prior to maturity or at maturity based on rating? So let's say any given period prior to maturity, a AAA rated bond will simply get the coupon rate. Notice I have a name range in B14. So as long as the bond is not matured and it's not in default or defaulted, I'm going to get 10% of my coupon, or 10% of par, which is just the coupon rate. If it defaults in that period, I'm going to get recovery. If it's already defaulted in that period, I'm going to get 0. Now, payoff 2 is a range right here. This is payoff 2. This is payoff 1. Payoff 2 are the same cash flows, or the cash flows, assuming the same ratings at that period. However, let's assume payoff 2 is at maturity. So at maturity, you're going to get coupon plus par. And again, this is just as a percentage of par. So at maturity, if the bond is a AAA rated at the end of the maturity, you're going to get 110%. In other words, your par plus coupon. I'll copy that down. If it defaults on the maturity date, I'll get recovery. If it already defaulted prior to that, I'll get 0. So these are all the possible cash flows before maturity or at maturity based on the rating at the time of the cash payment. Then I'm going to set up a little if-then statement. Now you could have just typed in zeros and a 1 here, but we're going to make this a flexible spreadsheet. I'm going to say equals if this rating right here is equal to this rating that's going to change, make that a 1, else put a 0 in that cell. So all this does is it puts a 1 under B, and if this were a C-rated bond, it would put the 1 where C is. I'll make it a B-rated bond. And I'm going to change this to calculation now. Okay, so I have my cash flows for every rating, the cash flows at maturity for every rating. These are my probabilities of default or defaulted for one period. And this is the current rating, which will tell you that we're talking about this bond right here. Now notice for a B-rated bond, I only need to know this row, and I need to know it for years 1 and 2, and then later we'll make this a 30-year bond, so I need to know for years 3 through 30. But however, if it's starting out as a B-rated bond, I just need to know this row right here. I now have my payoffs 1 and 2, my transition matrix. I'm going to now calculate my cash flows. Time period 0. I'm going to pay 90 cents or 90% of par for this bond because it's selling at 90. So I just have a formula there minus this cell right here, which I named price. I now have a formula here which I'm going to copy. I'm not going to make you type this in here because it's painful to do, but I do want you to walk through this because you're going to have to modify this for one of the assignments. This is the nasty if-then statement that we simply need to put here and then copy over for 30 years. And it'll calculate the cash flow in every year. And now notice look at this. The cash flow for year 1 is 11.56. Cash flow for year 2 is 103.38, and then they're all zeros. That is the same thing we did in topic 2. There's the 1156 and 10338. 1156 and 103.338. However, this is more flexible because now I can make it a 30-year bond. And these are the cash flows for 30 years. But before I do that, I hit undo. I want to calculate the IRR of this 2-year bond. I'll just put IRR and go out through 30 years, even though this is only a 2-year bond I'm doing right now. So there's my IRR. There's this 13.79% that we did and calculated in topic 2, 13.79%. However, this spreadsheet now works. I can do a 30-year bond. So the expected return of a 30-year bond is 912, given this price, coupon, rating, and transition matrix. And we also see the YTM. I use the YTM function here that I showed you earlier, and this calculates the YTM versus the expected return of the bond. So this one formula calculates the periodic cash flow based on the transition matrix, the maturity date in years, the cash flows prior to maturity, the cash flows at maturity as a percentage of par, and its current rating, which is a 1 here under B and the others are 0. So let's walk through this nasty little formula. If C27, now what is C27? It's the current period. So if the current period is greater than the maturity, 30 years, the cash flow is 0. So this is why, if I make this a 2-year bond, these cash flows in year 3, 4, 5 through 30 all turn out to be 0. That's because if it's matured, make it 0. Now there's 2 other conditional statements here. If it's matured, make it 0. If it's maturing, if C27 is equal to the maturity date, which is true for this period right here. So if D27 equals the maturity in years, 2 years, here's what the calculation is. It's a long calculation right here. It is a matrix multiplication of this inner part here, the ratings row times an M mult of the matrix power, this, to the second power times this. So here's what's going on. It's an M mult of this row times this to the second power, because we're talking about period 2 here, second power times this. So what it's doing is it's calculating the 2-year matrix power, this, and it's taking this row right here. And how it's doing that is when you take a matrix or a matrix multiplication and you multiply, say, this row times this transition matrix, and this row are all zeros with 1 on the B, what it'll do, it'll take that transition matrix and isolate this to the second power. In other words, it's going to grab the values of the squared transition matrix and give you these probabilities. It then takes these probabilities for the 2-year and multiplies times these cash flows as a percentage of par. And that's what gives you the 103.38 in year 2. Now, in year 1, it finds out that it's not matured because it is less than, this number here is less than the maturity. This is the last part of the matrix power. If it's not equal to maturity or greater than maturity, the last part, it must be less than maturity. And the only difference, instead of using this column of payoffs, it uses this column of payoffs. So this formula determines first, has it matured? If yes, make it 0. If it's not matured, it's going to use this part of the if statement. And it's going to take this ratings row here, the zeros and ones, and it's going to multiply it times this to the n power, and multiply. If it hasn't matured, multiply this, which is the cash flows as a percentage of par if it hasn't matured. And then the years in which it does mature. So if we make this a 30-year bond, it's going to use this one. So this 30-year bond, the 30-year cash flow, you'll see it's a little bit bigger. It uses the final payoffs. So these are all the expected cash flows as a percentage of par, and then the default adjusted bond return is simply the IRR of the cash flows. And the nice thing about this spreadsheet, I'll zoom out a little bit. It'll take any one-year transition matrix. You could change the price. Say this bond is selling at 80, has a 6% coupon, 40% recovery, and it's a 20-year bond that's currently C rated. Notice this bond has an 8% YTM, but the expected return of this bond is only 275 based on these cash flows prior to maturity, these cash flows at maturity, these probabilities, and that recovery rate. So this is the general model for calculating default adjusted bond returns. I then took that model and I got some Bloomberg data. I looked up this 9-year 8 3/8 coupon single A rated bond, plugged in my data. That bond is selling for 130% of par. So I typed in 130.69%. Had an 8 3/8% coupon. I just put in a recovery rate of 50%, 9-year bond, single A rating. That IBM has a YTM of about 424 and an IR expected return of 408 based on this transition matrix. And then I looked up a Sprint, a BA rated bond, had an 8 3/4% coupon, and it was a 20-year, 2-year bond. It was selling for 96.70. I put in the 96.70, the coupon. I put in a recovery rate of 50%. Again, our long-term average was actually 40-some%. Maturity 22 years. This bond had an 8% expected return and a YTM of 910. Last thing I want to talk about is most corporates are semi-annual payment bonds. That spreadsheet we calculated is for an annual payment. If we wanted to adjust it for semi-annual payments, we'd have to divide the coupon rate by 2 and multiply the term by 2. However, we'd also have to adjust the transition matrix to 6-month periods. So we have to take the square root of the 1-year transition matrix to get 6-month periods in some sense. And then we calculate the expected return based on these 6-month periods. And when we're done, we have to multiply that IRR by 2 to get to YTM. If you want to see exactly how to do that, you can see that in the Benninga textbook. However, we'll just use the annual payment bond model for this course. So in this topic, we calculated default adjusted bond returns. We started by understanding bond expected returns versus YTMs. Talked about bond ratings, transition matrices, and recovery rates. We created a simple 2-period model to calculate default adjusted bond return. Then we used matrix algebra to create an n-period transition matrix, and we used that matrix power function. And then lastly, we created that n-period model to calculate default adjusted bond returns.